makes a little more sense to go to chapter 8 before chapter 7. So I would jump from chapter 6 to 8. And we'll do a few days of this before the next week we'll start reviewing for the exam on Monday. All right, trigonometric ratios. We're going to start with a right triangle here. So right triangle is just trying to have one right angle. And we're going to just choose one of these corners. We'll choose this one, and I'm going to put a little theta symbol there that represents the angle. And we name the sides of a triangle in relation to this angle here. So in relation to this angle, anybody know what this bottom side would be called? So a little bit, think of it more in relation to this angle. Here, I'll help you out a little bit. This side over here is the easiest one. This is the, what is this called? Yeah, the hypotenuse. Anybody know what either of these sides refer to as? Yeah. Yeah, adjacent. Yeah. Somehow he says bottom one adjacent.
That's like I every time I say it's like I got
Jason, adjacent. Yeah. Jason says fine. So this side is Jason. This side. Anybody know this side now? Yeah, opposite. Right. It is opposite of the angle. So if the angle is here, this side adjacent, it's the one that's connected to the angle, but it's not the hypotenuse. The hypotenuse always has to be the hypotenuse because it's the longest side opposite of the right angle. If we switch this up to here, then these would actually change spots. Now this would be the adjacent, and then that would be the opposite. But if it's down here, the adjacent is there. Adjacent, that word, sometimes like older people will use it more. Adjacent, it kind of means next to. So the unofficial definition means next to. So it's the side sort of next to the angle, but it's not the hypotenuse. Like some older people will say, like maybe grandpa will say, like it's the adjacent house or something like that, or it's adjacent to the couch. You've ever heard someone say that before? Yeah, and that means like next to it. Adjacent to it, yeah. It's kind of an older word that really is much. Anyhow, that's what it means. So these are our three sides, and then we also are gonna identify our trig ratios using this angle. So our first trig ratio is the sine ratio. So we're gonna say sine of theta. Anybody know what the ratio of sine is? Yeah? Good. So it's the opposite side over the hypotenuse. So that's our first trig ratio. Next one would be cosine. Anybody different know that one? Yep. Cosine is adjacent over hypotenuse. And then we have the tangent ratio. Anybody else know that one? Okay. Good. Opposite. So you actually need to memorize these. You might be thinking, well, like, how am I going to memorize all that? There's a nice word that helps you memorize it. Anybody know what that word is? Yeah? Right. SOHCAHTOA. Probably heard that before. It's like this. SOHCAHTOA. SOHCAHTOA. Seen that before in geometry? Well, hopefully. Most teachers will give that word to you. It makes it a lot easier to memorize it because sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So that's the easy way to remember SOHCAHTOA. So whenever you do like a worksheet or any assignment, you just write out the word SOHCAHTOA. That will help you know all of these. You just gotta memorize that word SOHCAHTOA. Now there's 3 other trig ratios that match with these. Each of these have a pair. Do you remember what the pair with sine is? Yeah? Yeah, cosecant. CSC is cosecant. So cosecant of theta, if you remember when we did the unit circle, if the sine was the y, cosecant was 1 over y. You just flipped it. The same thing applies here. Cosecant, you just flip sine, so it's hypotenuse over opposite. So that's the pair that goes with sine. And then the one that goes with cosine is secant. So S-E-C goes with secant. So that one is the same. Cosine was x and secant was 1 over x, so you just flip this. It's hypotenuse over adjacent. And then lastly, the one that matches with tangent is cotangent. So cotangent theta, you flip tangent, so it's adjacent over opposite. So all you need to do is memorize the word SOHCAHTOA, and then you can actually get all 6. Because you write out these 3, and then you just flip them. That's it. Those are the 6 ratios. Alright, so these you do need to memorize in some sense, but you'll get them just as you use them. Alright, how we're going to use these. The first thing that we're going to do is being given a triangle. And we're going to find all 6 trig ratios. All trig 6 trig ratios. So if we're given a triangle, it has a theta in it, and it has a couple numbers. I'm going to just draw that out really quick. Draw a right triangle. Like this. Put the theta in here. 12 and 5. So with that triangle, we're going to find the exact value of all 6 trig ratios. So let's start with sine. So we're going to say the sine of theta Alright, so sine of theta, that, anybody know what the ratio would be? What is it going to be in this? 5 over something, but we actually don't know the hypotenuse, right? Because it's opposite of the hypotenuse. So we got to actually figure out this side. And that will be the case on all of these. You're only given 2 of the sides. Here we're given this side and this side, but we don't know what that side is. So the best way to figure that out is using what? Yeah, use the Pythagorean theorem, a squared plus b squared is c squared. So this is like our a, this is our b. The hypotenuse is always your c. Always your c, no matter what, hypotenuse has to be the c. So in this case, it will be 12 squared plus 5 squared equals c squared. And we first got to solve for c before we can actually do most of the ratios. So we get 144 plus 25 equals c squared. Yep, 169. C squared, square root, and c is 15. That's our missing side. Let's just go ahead and write it up there. It won't always be a perfect square. We'll see someone where we don't get a perfect square. So now we can go ahead and do it though. Sine is opposite of hypotenuse, so the opposite side is 5, opposite of the angle. Hypotenuse is 13. So we just write it as 5 over 13, and that's it. It's the simplest form of that fraction, 5 over 13. And then we'll do cosine. And what I would always do also, just write out SOHCAHTOA. So cosine is adjacent over hypotenuse. In this problem, since the theta is here, this is the adjacent side. So it's going to be 12 over 13. And then the tangent of theta, opposite over adjacent. So opposite is 5, adjacent is 12. Over 12. And then the other ones are actually easier because as long as you know which one matches up with which one, sine matches up with cosecant. You don't even have to look anything up, we just flip it. So you could, if you wanted to, you could do, well, what's my hypotenuse? It's 13, the opposite is 13. And then my opposite is 5. Or you can just flip it, just flip this. Cosine is secant, all you do is flip it, so 13 over 12. Cotangent matches with this, so you flip it. Cotangent of theta is 12 over 5. So those are your 6 answers, I think. Easy enough, right? Let's try one that's a little harder. Here's the next triangle. It also looks a little bit different. The theta is in a different spot here. Theta is up in that corner now. You know, draw a little sketchy real quick. Just triangle. Theta is up here, 3 and 2. So we know we're going to need to find the third side, so let's just go ahead and do that first before we do any of the trig ratios. We'll just go ahead and get that third side. This is still your A and your B. You got 2 squared plus 3 squared, 2 squared. So we get 4 plus 9 equals C squared. That gives us 13 equals C squared. Square root of 13, unfortunately, this is the square root of 13. I can't do it with these, so we just leave it as a square root of 13. So that goes here. And then we just go through and do our 6 ratios. Generally, it's always easiest just to start with sine, because that comes first in your SOHCAHTOA. Sine of theta. Now, since our theta is up here, the opposite side is down here. Opposite is 2. Hypotenuse is always the side opposite of the right angle to the side. Square root of 13. Now, what's wrong with that? Right. So we gotta get rid of that. We got to rationalize it. We just multiply by square root of 13 over square root of 13. That makes it go away. So we get 2 square root of 13 over 13. It looks more complicated now, but that's the correct math way to write it. So let's try the same with cosine here. Cosine is going to be the adjacent, which is 3, the adjacent side, over the hypotenuse of square root of 13. And we'll just do the same thing we just had to do where we got to rationalize again. We can probably figure out what it's going to equal. Write it. 3 square root of 13 over 13. Square root of 13 can't be reduced any. Also, these numbers in here can't be reduced, so that's what it is there. Next, we've got tangent, theta, opposite is 2 over adjacent at 3. And then we just got to flip them all. Sine matches with cosecant. Which one should we flip? Should we flip the final answer or the original? Yeah, flip this one. Because if you flip this one, then you got to rationalize it again. So just flip the original, make it the square root of 13 over 2. Much easier, then you don't have this bigger fraction which you then got to rationalize. Again, same with this one, we'll just flip the original answer we had. For secant, make it square root of 13 over 3. And then for cotangent, just flip 2/3. That's all there is to it. I wanted to show you at least one other one here. It's not much of it. Okay, so there's our question there. We got the square root of 5 and 1, so we got to find this inside. But the big thing to notice here is this is actually this. This is already the hypotenuse. So when we solve it, you can think of this as the a if you want to. It'd be like 1 squared plus b squared equals the square root of 5 squared. That's how we got to view it. Make sense? You can't just assume you take whatever the two are and make them your A and B. This has got to be your C in this one because it's not obvious. So when we solve it, 1 squared is 1, b squared is b squared, and the square root of 5 squared is just 5. So we subtract 1, b squared is 4, square root of b is 3. All right, now we're good to go ahead and find our ratios. Sine. From here, this is our opposite. Opposite of theta. 1 over hypotenuse, radical 5. So we got to rationalize it. Multiply by radical 5 over radical 5. So it becomes radical 5 over 5. Cosine, same deal, except it's adjacent. The adjacent side is 2. So 2 over square root of 5. We do the same thing, we just multiply by radical 5 over radical 5. 2 radical 5 over 5. Tangent, opposite over adjacent. Opposite is 1, adjacent is 2. So half. And then match them all up. Cosecant matches with sine. And again, we'll flip the original one. Don't flip this one because you don't have to rationalize again. Just flip this and just becomes square root of 5. Square root of 5 over 1 is square root of 5. This one, you flip it. Flip the original. Secant of theta is square root of 5 over 2. And tangent, when you flip a half, just becomes 2. So cotangent equals. I think you got it well enough to do some. So you've got 5 of these problems to do. You can probably get them done before you leave. That would be the goal. and it's already on Google Classroom. But, here it is. It's page 531, 10 to 18, the evens, and it's also on there too. The pictures up there as well. So you need to go through and do 10, 12, 14, 16, and 18. So make sure on 14, you're solving for like a B. It gives you the C. The same with on number 18. You're solving for a B and it gives you a C for that one as well. Otherwise, it's just going to be adding 2 and it can split it. Just be careful on those two. Okay. Let me know if you need some help or someone that's great too.